All right. So, welcome back, everybody. We are now moving on to chapter, I think it's 14 on broadly speaking, kind of like how to secure the connection between, you know, clients that will be using your server and your server using SSL. So I think that's Secure Socket Layer. I forget what it stands for. TLS, Transport Layer Security, and HTTPS. So basically, how to secure let's just say like how to secure traffic between, the clients that use your server, your data science server and the server itself. Um, I'm hoping maybe we can have a little bit of a discussion at the end if Diana and maybe others who join if you have more experience in this than I do. The bar is quite low. My level of experience is not high. Um, uh, But I'll present what the book presented, also with the caveat that I have not yet done the lab. I'm hoping to kind of batch do those over winter break, and maybe at that point I'll have something more to say. So this presentation just really reflects my kind of meager understanding from the book and a little bit of research outside of the book. So uh, given that I don't know too much, the learning objectives will be kind of right-sized as just, why use HTTPS, a little bit on how SSL and TLS work, on kind of like a little bit more of a detailed level. And then the third point is practical. Is like if you're looking to secure your server, how do you get an SSL/TLS certificate? Um, so now to the why. So I made this. So you'll see in what follows one diagram from the book, and then something I quickly sketched with Excalidraw to try to look like what was in the book. So this is my own crude sketch. So on the one hand, we have a server. On the other hand, we have a client that are communicating. And I want to motivate why secure the communication. So typically, our interactions with a server as a client, let's say it's a web browser or something else, you air quotes kind of go to the site. Then you may send some information to the site. And obviously, you can also, the reverse direction of travel is also true. You can receive information from the site. Um, so that's generally like at a very high level, kind of what the interactions, the communication you might have. So I want to draw our attention to the things now that could go wrong in that communication. First thing is that you go to the site or think you go to the site, but there's a risk that um, where you go may not be where you want to go. Instead, you could have some malicious actor who could divert traffic to a website that looks, I'll just say website. It's maybe easier to reason about. You go to, mybank.com and then you could end up going to that same server, but then in absence of any security, you don't know that where you're actually going is where you mean to go. In the past, we mentioned that none of us know IP addresses. I mean, we understand that they exist. We understand that they're used. But when I'm going to google.com, I'm not going to Google's IP address. I'm going to google.com. So a malicious actor could kind of set up a site and could capture that traffic. So that's the first problem. And then, without any other tools, you have no means of verifying that the site is what it claims to be. Second problem is that as you're sending information, if you're just sending this traffic, the way that HTTP, so let's drop the S, works is you're just sending plain text files in a data packet over the public internet. And anyone or like malicious actors could view that traffic and view the contents of that traffic. So if I'm sending, let's say, my authentication, my username and my password, let's say, then any malicious actor, knowing that this is in just plain text, could capture that packet and look at its contents and intercept my credentials and steal them, right? So without any protection in this communication, this is possible. So with just straight up HTTP, this is possible. So HTTPS is meant to really kind of to do these to address these two sets of problems. And now we're on to the diagram from the book. Um, and I guess maybe I'll come back to this. Is on the one hand that there's some certificate that when you go to the site that you can verify the authenticity of the site, that the site is what it claims to be. And then that the traffic that you have between the site and the client is encrypted. Uh, so the way it works on a little bit of a practical level is that, and I think this is a great diagram. The client, so let's say your web browser, you navigate to a website. So the first thing that happens is a little bit of I guess, a handshake of sorts where um, since TLS and SSL rely on public cryptography, like we discussed for the SSH, basically what the client and server will do is that they'll exchange credentials. So they'll basically exchange their public key. Um, and then the server will send its public key to the client, and then the client, so let's say your web browser, I guess your web browser on your system will then verify that public key against a store it has that would allow it to verify the authenticity of that public key. So using like a private key in the CA certificate authority store, it will basically say like, okay, this website is legit. I've received the public key. I can verify that it belongs to this website. Um, and then once the client verifies authenticity of the public key, then um, then I think they again exchange keys, and they generate like an open session where you kind of have this ephemeral key that basically has you have like an encrypted channel of communication between the two. This is my crude understanding, which may well be wrong. Um, so they'll share a key, and I think it's the same key for both. It's not, like server has one key, client has another key. It's the same key. It'll be the key for this session where they open this session of communication, and during that session they'll communicate back and forth through this kind of encrypted um, channel. And then if you come back to the same website, you'll go through the same process again, and then have a different session for exchanging information. So so far that's why. So far I've kind of briefly touched on why we would want to have an SSL or TLS certificate, basically to help us ensure that the site that we're going to is the site that it claims to be. Um, then also to kind of encrypt traffic between the two so that the data packages that go between the client and the server um, can't be inspected by anyone on the public internet. That the contents of them are encrypted so that only the two parties can see what's being communicated. No one else can. And this is like broadly how it works. And there's this great resource, excuse me, that in a little bit of just side research I found that really was super helpful. I think better than Wikipedia or the rest of Cloudflare. I guess not surprising Cloudflare would have a good article about security. But it goes into much more detail about, what is SSL, how it works, talks about this TLS handshake. Um, and other things in a lot more detail than the book does, but not in so much. I don't know. For me, it was the right level of detail. It was more detailed than the book, but not so much detail that I need to be a cryptographic expert to follow it, or someone who knows the HTTP transfer protocol like the back of my hand on a technical level. So it's a really nice article. Just put that in the slides. I can drop that in chat too if that's of interest. Um, worth checking out. Um, so far we've seen like why we might want to have an SSL slash TLS certificate, how it works, and you know now the question is okay. Hopefully, listening to this, you say, okay, yeah, I understand now. I need an SSL certificate. How do I get it, and how do I apply it to my server? So I think they're kind of forgetting it. They're two different tracks as far as I understand, and this is based on my kind of experiences that one track is that you buy you buy the SSL certificate from a CA, so a certificate authority. So it's one of these authorities that has the ability to generate these certificates, and also um, make it such that people visiting websites, can readily verify the authenticity of their certificates. So they can kind of like create their certificates and sign them and say, this is good, and then kind of distribute that information such that, people visiting sites can verify that information. So I see kind of like two little bends of like kind of providers. One I kind of jokingly call like big CA, I guess, a little nod to like big pharma or big oil or something like that. There are lots of, I think, big providers. The one that I know best is Komodo. I think there are others as well, whose principal business is around this. Um, so you could go there and directly buy this separate from any other services. So if you just need an SSL certificate, you can go here and buy it. Alternatively, so I'm not sure I've done this path before. I've seen other people go this path. Um, what I've done more in the past is that, if you're working with some kind of service provider that provides, let's say, infrastructure or a site hosting service, and then other services around that, those kind of what I'll call like end-to-end providers can provide you with an SSL certificate. So in the case of AWS, for example, perhaps there are other ways that they do this, but in AWS, I've spun up some infrastructure in the past where I'll have kind of like a little group of resources, a compute instance to run a site, a relational database behind the scenes to kind of capture the information, put those in the security group, put a load balancer in front of it, and then I think oftentimes when you get the load balancer, AWS will kind of throw you a bone and give you an SSL certificate that you can put on there at no cost, or rather, they kind of bake it into the cost of the other services. I think this is also true with other providers. If you're just doing a website, GoDaddy, probably Wix, and all these other Squarespace, all these other providers have the same thing. So depending on kind of what other things you may be working with and what your actual needs are. So, if you want end-to-end stuff and you're working in AWS or Microsoft Azure or Google Cloud, all these big infrastructure, cloud infrastructure providers, probably they can give you an SSL certificate somehow, maybe in ways that are easier than what's described in the book. Or if you're just doing a simple website, maybe you can go with GoDaddy, Wix, etc. So that's one route. You can buy it.
I have
Um, yeah.
sorry. Yeah,
No, go ahead, please, please.
one question there. So now everyone is required to have an SSL certificate, right? Because yeah, like even if it is only a web page that will just like display content, like the
Yep.
browser will flag you, and it's actually the browser's kind of like responsibility to check that, right?
Exactly. So I think now I was reading about this. I think there's a push from Google Chrome and Mozilla, maybe others as well, but definitely those two, to sort of, this isn't quite the right word, but like, let's say blacklist, HTTP sites that don't have, don't have an SSL certificate. So at a minimum, like what they do is if you try to go to these sites that don't have an SSL certificate, I've seen in the recent past is you'll see like an overlay screen in your browser. They'll say this is insecure. It does not have an SSL certificate. Are you really sure you want to go here? And then sometimes maybe you just can't. I think they're maybe in future going to make it such you can't even go there on the public internet, right? As a means of like protecting end users, I guess. Um, so I think there's been a push to do that. And so like I guess your question is like, okay, well, if you're just doing mypersonalwebsite.com or something like that, like, well, do I have to go through all this mess? And this is, I think, where it comes to like there are ways that you can get an SSL certificate for free. Um, and so I think at like the very maybe the most basic level, as I understand it, um, an SSL certificate on some levels is sort of not so different from an SSH key, right? So you can generate it. And there are tools where you can generate what's called like a self-signed certificate. So you generate the certificate, and then there's no certificate authority. So this authority that says, I verify that this site is what it claims to be. That the person who's attaching the certificate to their website controls the domain. Um, uh, there's no bigger entity that can kind of vouch for that. It's sort of a like trust me, bro. Like you sign your own certificate, you put it up there. And I'm not sure how browsers handle these things, but I think this is
Yeah,
technically possible.
yeah, that's what I was gonna ask. Like, do browsers have like a, yeah, do they actually identify these certificates? Because at the end, like, yeah, like you said, it's a different level of trust if you just say like, yeah, please trust me, right?
Yeah, because I think you can go, for example, into, or I'll just do the book website. You can come and you can actually inspect the certificate right here. Connection is secure, and then you can look at the details. It's secure, is valid, and then you can see more details about it. And then I think you can see in certain cases, who the certificate authority is. You can see this is an SSL certificate that's issued by Komodo, for example, and that it expires at such and such a date. So that's basically metadata that I understand that you can see even through this interface. Like you can open this up and you can see like what like some stuff right here. Here's the public key, here's the certificate. Yeah, so you can inspect some of this information. Um, and I don't know what would be there if it's self-signed. I mean, I guess either the like if it's a standard format for the SSL certificates, like if there's a JSON has a regimented format of what's valid JSON. I don't know if there's a format for SSL that would basically say what it looks like, and then if there are like fields that are optional, like who the who the certificate authority is that issued the certificate in this case. Like the other thing which is really more interesting is you can use this tool right here, which I think has grown over the past, and I don't know when this started, but um, you'll see Acme, so not to be confused with the Looney Tunes company that gives like Wile E. Coyote weird stuff. But there's the automatic certificate management environment, yeah, which basically is a very uninformative name unless you understand what it actually does. But I think basically what it works, and here I guess I'll just go to the next slide, is probably maybe you've heard of, I'd kind of heard of, but not really dug into, like Let's Encrypt. Have you heard of this one, Diana?
No, not at all. No.
So it's a really interesting organization. So I believe they're a nonprofit that is supported by lots of different players. Whoops, sorry. Um, sorry, you still seeing my screen?
Yes, with your presentation, yes.
Okay, thank you so much. Yes, sorry. When I went to select the tab and the Zoom overlay
Mhm.
came in, and I thought I had unshared accidentally. But so let's encrypt. From what I understand, they are. I think they do a couple things. So I guess we'll stay with this for a second. Um, They provide tooling that helps you automate SSL certificate provisioning, where your client can generate a certificate, and then they automate the process that in the past I think was manual. Like for example, if you go to Komodo, I think this is manual, where like first there are different ways that you can prove like your bona fides, like prove that you own the domain, or prove that you own the server and I guess the domain. And one of them that they use is called domain validation, where basically they automate some checks where they have the certificate authority can say like, okay, like Arthur-Shaw.com, we can verify who owns that and that the person who is requesting a certificate controls that domain, and we can issue a certificate to the effect that they actually control that domain. Because, like part of the SSL TLS part is just like you control this website, that you are the rightful owner or controller of this website. And then once you have proven that you own the domain, then it automates the process of taking actions on certificates. So it can issue you a certificate, and then Let's Encrypt, from what I think I understand, is also a certificate authority that's recognized. And so basically it can issue the certificate and be signed by Let's Encrypt, which is a trusted certificate authority. And also you can revoke the things. Like let's say you want to pull down your website and make sure that nobody um, you know, captures your certificate, or I don't know what the use case would be, but you can get rid of the certificate. So Let's Encrypt does this, and then I think they're a nonprofit. They've set up all this infrastructure, yeah, based on the global made by contributions. And so if you look down here, it kind of looks like a little bit of the who's who. Well, maybe not entirely this, but lots of tech players, not surprisingly, who want people to be able to access websites, and who probably want to be able to reduce the friction around provisioning of SSL certificates are big contributors. Chrome, AWS, Mozilla, Shopify, Netlify, not surprisingly, you're going to find here. So I think they make contributions to this, so that Let's Encrypt can do its work. Um, so basically, you can like automate this work so that you can get your own SSL certificate for any website that you bring up. And there's this article. Oh wait, I still have it. No. It goes into a bit more detail about how this Acme process works, this Acme protocol, I guess it is now. But yeah, first, like I said, first step is they prove, there's validation that you control the domain, and then you can get the certificate, and they go through a bit more details about what that involves. So in this way, you don't have to go to what I was kind of cheekily calling like your big CA. You can just create your own certificate um, for free, uh, using using this protocol and using the free certificate authority of Let's Encrypt. And recently, and perhaps I'm adding information here that is misinformation, but I seem to recall that in the current administration in the US, um, took issue, I think, with some stuff that Let's Encrypt is doing. They worried that it might pose some security issues. And so I think there are some issues around funding for Let's Encrypt. So I think there's some public funding that went to Let's Encrypt. Let's put it that way. And I think that was um, at risk. We should all do our research, but this is what I think I remember. And as I was putting together the slides, I was wondering, is there any other game in town? Are there any alternatives to Let's Encrypt that would allow you to do the things that Let's Encrypt allows you to do without going to Let's Encrypt per se? And it seems like there are some, but as best I could tell from some quick searches, it seems like they are freemium providers in a certain sense. So I think these you can get a free level of service, but then there are also paid levels of service. I didn't go into the details to look and see where that line sits, but so all that said, like I don't know if there is a true alternative to Let's Encrypt here, because I think the piece that's missing is probably like this. Well, maybe there are multiple pieces, but it's like you need to have a certificate authority that's trusted and a process that's trusted by all of the stakeholders on the internet. Um, but yeah, that's how you would. I think that's how you would do this. And so the book in the lab actually shows there's a. I didn't do the lab, but I briefly scanned some of the steps, and actually this is in the slides of the first cohort. Is that there's some I think there's a Python package called certbot or something like that that helps with some of the steps of provisioning here. So in terms of like the practical what I do, I'm honestly not very clear on yet, but I know that this is a very popular um, let's say service provider that would enable you to get an SSL certificate for free. Um, if you know they can, if their protocol would allow you, if if you could automate this step right here, then they can give you the SSL certificate. I'm not sure at the level of details, like, okay, do I get a file and where do I put it in the file system on my server? I don't know that level of detail yet, but that's kind of yeah. I guess that's it. I guess I'll stop there.
Uh,
And,
Thank
and
you.
see like if you have any more questions. I actually had some other questions too that maybe you'll know the answer to, and maybe you won't. I don't know.
That's really great to know. Like it actually sounds like a task that the community can do. Like, like if you have to like trust that someone is actually like who they say, like that sounds like something that multiple actors can do, and that sounds like a
Absolutely.
task that is suitable for a community. Yeah, and I didn't know about Let's Encrypt. It's a great resource. Mhm.
The one thing that I was kind of wondering about, Diana, and maybe you have some insights too, is, if you come back to this one diagram right here, and I'm kind of like raising this issue because it touched on a problem I had at work, and I'm wondering the extent to which this is a problem people face in general when um, standing up a server. Is the following. So maybe let me describe my problem as I understand it, and then I know you've got a lot more experience with Linux and servers than I do, so maybe you'll get it. But um, so
But
I
yeah,
had
but
W.
just to let you know, I've never like actually been through this process of buying or getting a
Got it.
certificate or anything. Yeah, that's something that I haven't done. Yeah, when I
Oh, okay.
like when I work on like actual like apps and all this, I think that was already taken care of.
Got it. Got it. Okay, that makes sense. And or it might sit behind like so the book kind of talks briefly about this is that, this is a concern, like this is mainly a concern if your server is accessible to the public internet. If everything is behind like a firewall that it can't be accessed, it's not opened up to the public internet, then you could have HTTP, right? If you trust like within that firewall that everything is good, you're not going to leak secrets or any kind of data, then you don't necessarily need HTTPS. That could be like another consideration for people's work. But as soon as you have it on the public internet, you really need you really need an SSL or TLS certificate. But like the problem I faced at work, which is maybe a little orthogonal too, but I still feel is somewhat related to this, is I got so I'm working, I'm working on Windows. That's what's provisioned for our computers. Um, I requested and got WSL enabled on my computer, and uh, at least I don't know if this is generally the case for WSL or just the way it got deployed or internally is it's not batteries included. So you get, I install Ubuntu, it's there, it works to a certain level. But it's not ready to rock and roll as if it were just a, desktop instance that would expect to connect with the internet, so on and so forth. And I had some connectivity problems where I was trying to get some stuff off of the internet. Some things would work, some things wouldn't. And at the end of the day, what ended up being the problem, and it really surprised me, now I'm finally getting to my point, is that when I was working with a website that had a TLS certificate, I was getting, I think, a curl or other error saying like it couldn't verify the authenticity. And the issue was that on WSL, like just deployed with, no batteries included, there wasn't this certificate authority, like CA root certificates. I think they're like PEM files, or no, wait, that's AWS. Forget the format on Linux, but and so like what I ended up having to do is take, the things that are on the Windows device, or like the networking team kind of took the all the things that were on on the Windows side, and then I just there's used a Linux, there's a way that you can convert certain formats to the format Linux needs, and then you can put it in a certain place. I think it's an Etsy folder, Etsy, I think SSL or something like that. So that basically when you have this a TLS handshake, this step three of validate, you're actually using the CA store that's like, let's say, fully provisioned. So like my question in all this, I guess, is, and maybe this is an issue more for clients than for servers. Probably this is actually not more, but probably this is only an issue for clients now that I'm talking through this is like, how do you provision the store? Um, I guess on the server side, you don't need to, I mean, you don't need to validate the client, right? It's more the client validating the server. You just
Yeah.
need like authenticate, which would be a different route. But I'm wondering, like, if for servers, you need to come up with a CA store. Does this make any sense, Diana?
Yeah.
Or is this like a
Can,
complete aside
so,
on a different domain? I fear it is.
mm, yeah, maybe because I have no idea. So you got the certificate and then you set it up, but then the certificate was not like, I don't know, talking to the CA store to be able to like get the like yeah, the backup, or like saying that
Or it
that
was really more like, so I didn't, in my case, I didn't have a server. It was WSL on my own, on
mm,
my workstation,
okay.
not operating as a server. So I just had Linux there.
Hmm.
Um, and so when I had WSL enabled and, it's Ubuntu 24.04 on that I have installed, it didn't have the certificate store. So when I was trying to connect with the internet, where I needed to do this validation step, my client, like basically my computer, I didn't have a CA store in a sense, or like a broad enough CA store that I could like verify the public key that the server was sending of the sites that I
Oh,
was going
okay, okay,
to.
okay, I get it, I get it.
Yeah.
And yeah,
But
no,
so I was
I
basically
don't.
wondering, like, it doesn't show the CA store on this side. And I was kind of wondering, like, if you're standing now, like, so like one thing is like my problem, which is on the client side. And I was just kind of wondering, like, if you need to think about that on the server side. I don't think you do because I don't see the validate side on this here, but nevertheless, I kind of wanted to raise that as
Do you think maybe like if we like if you're going through a website like using the browser, like the
yep.
browser does that kind of like this the CA store thing, but then when you're not going through a browser, that's when you have to actually install like something else
Yep.
or
Yeah,
yeah.
no, you put it exact. Well, so I think however you're reaching a web resource, I think behind the scenes, your system, this is my mental model, which could be wrong, is that it's there's always this validation step. Um, and so like whatever tool you're using, if it's a browser, if it's curl, it's or something, it's going to be checking the CA store as you receive this public key from the server, the site that you're going to. And my issue was that, like on the Windows side, I have a well-stocked CA store.
Yeah.
On the WSL side, I didn't, and that was why like things weren't connecting.
Yeah. Yeah, that could be, but yeah, I don't know. I don't know how that works. And yeah, like that makes sense when you said that servers might not need to have like that handshake because they are getting the requests, right?
I think that's right. I mean, at least that's my mental model.
Yeah, because it's not like they validate the client. Like, I mean, they trust that the client is who they say they are, but like there's no need to validate the client until like they do their own authentication, like if they
Yeah.
actually. Hmm. Yeah.
Yeah, the only way in which like the server would expect the client has something, and I think the book kind of alluded to this if I got it right, is so I guess if you were doing the self-signed certificate or something, so I think there's also like a part where on the client side, your CA store would need to have content such that you could validate the public key sent by the server. If you're not going through a certificate authority, this is my crude mental model. You know, like if you're doing your self-signed certificate, then 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 you would need to like have an additional thing in the CA store. You'd have to distribute that to each client that you want to connect with the server. Because otherwise they wouldn't have info in the store to validate.
Okay.
And I think part of like I don't know whose responsibility this is in the internet or how this works exactly, but somehow like I get the sense that if you go with the public CA store, it somehow disseminates that information. Um, I'm not quite sure how that works though.
Hmm.
Because I'm just thinking like you know, it's like how does my computer and how is my computer able to like check the authenticity of like it seems like 0 day things. Like I spin up a new website and a new domain
Yeah.
um, today. In 1 hour, I can go to that website. How does that magic happen?
Yeah, I guess yes. I guess that relates to the like to the previous to the previous chapter and how like all these like tables like network tables get distributed around the internet.
Well, so
And
that would help with like that would help with the routing traffic, but it wouldn't help with this part right here.
yes, yeah, yeah, no, it
And so
wouldn't
I
help
don't
with
know.
that.
I don't know how the CA store gets updated actually on the client side. And if in practical purposes, like this may also be just one of those things that just works and we don't have to think or worry about it. But yeah, my WSL experience got me thinking about this, or got me paranoid
Yeah.
about this.
Yeah, no, you're right. Or maybe there are only like a couple of entries. Like that's something the client doesn't have to update that many times, and there's just like a couple of like single entry points where all of those certificates live. I have
Yeah,
no
I
idea
think you're
that
probably
it.
right that there are like accountably few CA like certificate authorities, and like as long as you have like the private key of those, you're good. Um,
Yeah, it could be so. Oh man, like every time we find out something like something else about the internet, like I'm always amazed by how this thing works. Mm, yeah, but
yeah,
that will be something cool to know. I'll try to do some research.
I think I'll hit up ChatGPT or my favorite LLM and try to see if there's a sensible answer I can extract from that.
Yeah.
The problem with these things always is, and this is I think why I love this article and this article is that the information is out there as best I can tell, but it's not always intelligible by me. Um, it's like sometimes it's written for a much more technical audience that has a much better mental model for like detailed mental model for a lot of technical things, and they're just missing one little piece. Whereas for me, I'm just, the internet is a magical thing that just works, and I've not thought about how it works. And I'm
Yeah.
not aware of all of the protocols and things behind the scenes that make it work.
Yes, I guess we're kind of all there.
Yeah. But at the same time, like there's probably only a subset of those things that I need to care about. And that's also the problem is to know what you need to know.
Yeah.
Um, which is why this book is helpful. Super
Yeah, yeah,
helpful.
and there will be like very few times when you're actually needed. So we're fine.
Exactly. Had you ever worked with there's other thing that I'd seen mentioned and I don't know if it's a competing thing, but traffic. I think it's Traefik.
No, not at all.
Oh, okay, so never mind. This is an alternate. Sorry, it looks like it's a proxy server just like or a reverse proxy just like Nginx. Okay, I guess that's what that is. In my mind, I was thinking it was an alternate to let's let's encrypt. I would also like to see like I don't know how much this can be automated, but so work, some colleagues that kind of sit, let's say, like functionally adjacent to me, let's say that they're developing some software and that enables clients to take the software and basically deploy like a server for data for survey data collection.
Okay.
And they have a Docker image that just like spins up all the necessary stuff, right? Or I shouldn't say Docker image, they have a Docker compose file
Mhm.
that pulls the image and then does lots of other stuff to set things up. It'd be interesting to see if some of this stuff could be reduced to a shell script. Um, Probably so.
Yeah, I feel like if they could be like someone will already have the the answer because I'm guessing like that's something that it's like a common thing for some people.
Yep. Yep. Yeah, I mean, I guess there's some interfaces like sorry, am I in the right chapter? Here we go. Yeah, I think this is Nginx configuration. And they mentioned cert bots somewhere. There we go. Okay. Yeah. Anyway, something to look into. I mean, at the very least, I know that this exists. I think this is a Python package. Cool. Well, I think that's all that I've got, Diana. Maybe a little bit of administrative stuff. Do we have anybody for next week?
I think I ended up signing up for next week. Yeah,
Oh,
thank you. Oh,
fantastic.
Manjak is here.
Fantastic.
Manjak is here too. He joined like in the middle.
Ah, oh,
I
fantastic. Hey,
Hi.
Red. Awesome. So I guess we're only missing then the last two chapters in terms of coverage.
Yes, sounds good.
Oof.
I'll probably take one of them.
Okay.
I'll just have
This one could be a very juicy topic. I don't know how it's covered there.
Yeah.
Because there are all these things I kind of want to learn a little bit more about because I feel like this at work, this is in the near future for me of having like these curated package repositories that are internal. Um, like one I'd heard is a JFrog, Artifactory. I don't know if there's just two different things or Artifactory is a JFrog product. And there are a few others like that. And I think maybe even Posit Package Manager might
Mm.
enable you to, yeah. This might actually be one where I don't know if there have been any developments with Posit Package Manager that would inform this.
Yeah, no,
Anyway,
I have no idea, but yeah, that sounds like it's gonna be interesting.
yeah, cool.
Okay.
All right, see you guys next week.